Scientist Smith here, bringing you safe, fun science experiments, hands-on activities you can do at home in the comfort and safety of your home. As you can see, we have a lot of materials on the table here today. We are going to explore what's called the states of matter. Everybody say matter! Matter! So I'm going to be saying a lot of vocabulary words throughout this video. I want you to challenge yourself and say them with me. If you don't know them, take it even a step further and research it. See what it means. See how it's used in all different fathoms of science, technology, engineering, art, and mathematics. All right, so as you can see, there are a lot of materials here. We're going to go through 3 activities. Those activities really require you to be very safe. First things first, when dealing with science experiments, you want to be safe. Safety is very important. So I have on my eye protection just to be safe. I have some gloves over here just to be safe. And I have on some protection for my body, my lab coat. And also be cognizant of the area that you're going to be working in. You want to make sure that when you're making science experiments, they do sometimes cause messes. So you want to be able to clean up after yourself safely. First experiment, we are going to explore solids and liquids. Those are 2 states of matter, solids and liquids. As a chemist, which I'm a chemist, I deal with solids and liquids all the time. I utilized what's called the periodic table of elements. Everybody say element, element. Some of you may know what the periodic table of elements is. Some of you may not. I guarantee most of us know what some of the elements are. For instance, hydrogen and oxygen. Those are 2 very key ingredients to this thing right here. Water, exactly. H2O is what we call it in science. But water is just one type of molecule. There are all different types of molecules. Molecules are different elements that are compounded together, called compounds. There are tons and tons of other elements on the periodic table of elements, such as gold, silver, lithium, argon, krypton, titanium. There are tons of them. Aluminum, we use aluminum all the time. Carbon, which is the building block of living organisms. All right, back to the matter at hand. So the matter that we're going to start with today is cornstarch. So everybody grab your cornstarch. Cornstarch. So cornstarch is what state of matter? What do you think? Take a guess. A guess is a hypothesis. Another word for a hypothesis is an educated guess. So we don't just do any type of guess. We want to make an educated guess. Something that we know is very plausible, that has some type of reasoning behind it. So if you guess solid, you were correct. So let's open up our cornstarch. Now when you open up cornstarch, you got to do it very carefully and slowly. This stuff gets really messy. These are very small molecules. This powder, as you can see, you go ahead and grab a spoon and take out a spoon and just sift some onto your plate or your bowl, whatever you have right here. You might have a plate right here, a platter or a dish rather. And you want to make sure that you get the whole bottom covered. And as you can see, look, that goes everywhere. It's very small, fine powder. And I'll just dump a little bit more on here. There we go. Now, just want to make sure you have a nice amount on the bottom. Eventually, we're going to add more and more as we go. But we'll set this to the side there. As you can see, it does get a little bit messy, so be very mindful of where you're working at when you're doing this experiment. To make this more fun, everybody loves fun, and of course this is just plain powder. We have food coloring, so you can use your choice of food coloring. I chose blue food coloring today. We'll put that to the side. Right now what I want you to do is take your finger, just one index finger, and feel the cornstarch. Just feel it, just take it and press it. You can feel it, feel how cold it is, feel how soft it is. Now very important. In science, we do not eat or drink because this looks like powdered sugar, this looks like flour, this could be mistaken for all sorts of things that could be harmful to us. So when we're doing science experiments, very important, that we do not eat or drink. Good job. So now we'll take our food coloring, and what we're going to do is just take our food coloring and drop wise, add a drop in just 4 corners, maybe a center one if you'd like. All you need is just a few drops of your food coloring. Then we need our water. So our water, we don't want to pour from this giant container because there's a lot that can come out really, really fast, and we don't want that. So you can just transfer that into another container like so. And again, we don't want to add a lot of water to this at first because we have to think about what's called concentration. Everybody say concentration! Concentration! Concentration means a lot of different things in different types of terminologies. For instance, you've maybe concentrated really, really hard on studying or focusing on something, or concentrate on a thought or a memory, or concentrate when you're doing a sport or some type of extracurricular activity or type of focus. But in science, when we say concentration, we're talking about a ratio between 2 different things. In this case, we have water and we have cornstarch. So we have a solid and a liquid. So right now, we have 100% concentration with the exception of 5 dots of food coloring, but 100% concentrated cornstarch right here, right there. Now what we can do is slowly add in water. I'll take this and pour just a little bit in. So as you can see, I'm not pouring in a lot of water right now. What I want to do is just pour it onto the food coloring because remember that food coloring is soluble in water. Everybody say soluble, soluble. So solubility is just the way of saying it if you're going to talk about its property. So, or it's soluble in something, or it has great solubility in something. Food coloring is soluble in water because it dissolves. Most things that are soluble in liquids so that they dissolve and break down. As you can see, if you're looking at your plate, go ahead and take your spoon. You don't have to get your hands dirty just yet. What you want to do is just kind of move that water over to some of the solids. And you may feel some resistance. You'll feel some resistance because that water is mixing with the cornstarch. But as you do that, you're creating a different type of mixture. First it was just cornstarch, and then when you add the water to it, you'll feel some type of resistance. Now, I'll pull a chunk up right here. Here's a chunk. Now this looks like a clump, right? It's a big old clump of cornstarch or chalk or Play-Doh. Now, if I want to try to mold it, I'm going to try to mold it into a ball. What I want to do is take some water, pour another little puddle of water onto your plate or into your bowl, and then just move it around over the water a little bit. So now, this was once a solid, but as I added water to it, you can see now it's starting to move a little bit. So I'll hold it right here, and you'll see as gravity pulls down, the weight of our what's called Oobleck. Everybody say Oobleck. Oobleck. That's the name of this material. Oobleck is, as you can see, there was a little drip right there because I dipped it in the water. But it's starting to act like a liquid, but it also has solid tendencies. As you can see, it's just hovering right there. Look at it. It's just sticking, and eventually it broke off because it weighed a lot. So that matter has more weight. And as it has more weight, it then drops because I had it from way up here opposed to way down here. So that's potential energy converted into kinetic energy. So for instance, as I pulled it up from here, I'm increasing the potential energy for these molecules to drop down. So now there's kinetic energy because if I flow this and hold it right here, there's still potential energy in there, but that energy only comes about if I was to allow those molecules to slowly drip down, just like you can see there. I'll come over this way so you can see. Drip, 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 and just kind of spoon that around. So right now you can see as I pull it up, look at it. It's kind of like a river-ish. So I'll pull this off right here. Now there's a clump. There's this clump again. More even, so that I don't have too many solids just kind of hanging about. And fold in all of your solids into your liquid right now. Just fold those on in. And it looks like it's moving like a liquid, but remember, it has solid tendencies as well. What we call this is a non-Newtonian fluid. It's a very, very interesting term. Try to say that. Non-Newtonian fluid. So non-Newtonian fluids all act as if they are solids and liquids at the same time. So as you can see, this, if I push on it, it's pushing back. So the laws of physics tells us when you push on something, it pushes back with the equal but opposite force or energy. So right now, I'll take this and I'll scrape it. And try to at least so that y'all can see. So as I pull this up, it's really giving me resistance to pull that up. It's really, really tough. But if I scoop it, and I just let those molecules in there relax, this oobleck starts to take on more of the properties of the water that's inside of it. But just like if this right here, this has more matter. And since this has more matter, it has more matter that can push back. For instance, this water has less matter. So the water, it just absorbs and kind of rests on there. And there's a lot less molecules bonded together. We'll get to that here in a second. Actually, let's get to that now. So this, right now, you can say it's probably about 50-50 solid to liquid. What you want to do, take your cornstarch back out, get just one spoonful, and dust it over it until you can see that it's starting to become a solid. You want to just dust it. Maybe about 3 scoops. That's what I just did here. And what I'm doing now is just putting some cornstarch over here because I'm now increasing the concentration or ratio of solids. So as I increase the concentration and ratio of solids, now you can see this starts to become more like a solid. I'll hold it up for you and do that. Now I'll try to keep it from flowing out. But look, as I try to, look, now it has a lot of force and I'm crumbling it off. But it crumbles off and still has some water trapped inside of our cornstarch, right? So a cornstarch mixture still has some type of moisture. And that moisture is allowing this cornstarch to still act as if it is a liquid. So I'll pull this clump off right here. See? So this right here is solid, but it's very, very bendable because when I let the molecules relax, I don't push back, the liquid starts to take over. And as you can see, it's starting to slowly, gradually drip down. And as it drips down, the weight of it will then decide it at its breaking point to snap off, right? There was a breaking point. But then it starts to take over, and there we have more and more detachment as the weight of our matter takes over. But that's cornstarch and water. Oobleck, the term was coined by Dr. Seuss. You should go read that book if you haven't. It's a pretty cool book, and reading is very fun. So, Oobleck. What I'll do now, just so that I don't make too much of a mess, I'll put my gloves on for this part. For you at home, if you're about to get messy with the oobleck, you can decide to either put on gloves. Please, please, please be sure you're not over a carpet. You want to make sure that this stays on an even weighted surface so it's not going to topple over. What we're going to do next is add in water until it gets to more of a liquidy consistency that's similar to slime. So I just splashed in a little bit of water there, and I'm gonna move a big clump of it around, and I'll pick it up so that you can see exactly what I'm talking about when I say slime. So here we go, Yeah, look at it now. So you can really see as I have my gloves on, I'm able to work with it a little bit more without thinking about it getting stuck in my fingernails having the blue dye stain my fingers. Regardless, the blue dye does wash off. It's washable. But also, take your fingers and just rest them on it. If you rest them on it, you'll see and feel that your fingers just slide in ever so soft. Slide right on in. But if you were to push on it, so as I'm pushing on it, it pushes back. And there's nothing actually going on with it other than the molecules are coming together and seizing up and acting more like a solid. So as I push down on this, I even have a hammer here. A hammer. This hammer actually should break this glass, or it's not glass. This hammer should actually break this plastic, but actually it's not. And I'll pull up some here, and see, there's still liquid properties, but again, there's nothing on there. Well, oops, there's a little bit that got back, just stuck to it. But you can push down on this and it'll push back. When there's a lot of force applied to it, the molecules act as if they're solid. But when the molecules are really relaxed, you can see that they loosen up and they mimic more of a liquid type consistency. Sorry, this is fun. And this is fun. Like it's fun to play with. Just make sure you're doing it in a nice controlled environment. So you can do this as much as you like. I'm going to transition into another experiment for us. So I'll let this all drip down. Drip, 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 drip. There we go. And remember, now we've increased the concentration of the liquid, so it acts more like a liquid. So increased learning. You could do this in 3 different trays, or 3 different plates, or 3 different bowls. Do one highly concentrated and solid, and do one 50-50, and then do one highly concentrated in liquid. And then you can see the difference between the 3 without having to do 3 different experiments in one single dish. All right, next experiment. So you're going to get out your cup, your cylinder, whatever you have handy that is a tall glass. I have a cylinder here that has a little shape to it. What we also need is our water. We need our oil. We need our anti-acid tablets and food coloring. Food coloring, I chose to do some pink today, or red. What we're going to do first, take our food coloring and add a drop to our cup or our cylinder, whichever you have. Set that off to the side. And what we're going to do now is talk about surface tension and how different types of liquids do not react with one another, let alone they don't like to touch or mix or blend with one another. Those 2 liquids that we're going to deal with right now is water and oil. So take some water and just pour that water into a cup, a separate cup. So as you pour that water into a separate cup, that's what you got there. So we have our water, and then we're going to add some oil. So take some oil and just slowly add oil to it, just like that. And you'll see the oil doesn't go beneath the water. Wonder why? So the reason why is because this oil has a different weight than the water. So this oil obviously weighs a lot less than the water because the water is on the bottom. Even if I was to take this and put it in a bottle and shake it up, shake it up. You can try this to increase learning. Find a jar or a bottle, mix it with oil and water, seal it up and make sure it's nice and sealed tight, and shake it. Shake it. And as you shake it, you'll see that the water and the oil does not mix at all. This is just a simpler version of it. You can see that there's a fine line between the 2. And that's that. So now we'll set that off to the side and we'll get to this. Get your cylinder and add in some water. We do not want to add in a lot of water just add in 1/4 of your container. Boom. 1/4 of our container. Water. Put this over here. See if I can see a little bit better. There you go. Water. Water. So this is now red water or pink water. Then we are going to take our oil. Now with our oil, we're not just going to splash it in really fast. What we want to do is let it slide down the side. Let it slide down the side of our cylinder or container. And you'll see that it will start to rest on top. So just put in a little bit. If you put in a little bit, you'll see it really, really well. That oil, just like in our cup here, is very, very lightweight and is resting right on top of our water. Just so happened to be pink water here. So I'll take some more oil, and we want to fill this about to the 3/4 mark of oil. I'm going to leave some room for it to breathe on top. There we go. Set our oil off to the side. Now you can really see the difference. See how the oil, even though there's a lot of it, is weighing down on the water. See? Next, we want to get out our anti-acid tablet. Anti-acid tablet. So go ahead and open it up. Feel the solid. Examine it. If you want to take this a step further, you could research some of the ingredients that are on the back of this. See what it's made of. See how it's utilized in different types of industries. See what this actually does once it hits your stomach. This is an anti-acid tablet. It's going to create gas. That gas is called carbon dioxide gas. Everybody say carbon dioxide! Carbon dioxide! So carbon dioxide is a mixture of two elements. One element is carbon, and the other element is oxygen. So when we put them together, for instance, there's one carbon and there's two oxygens. That's why we say dioxide. So carbon dioxide, one carbon, and the two oxygens come in contact on the sides. So that's what that molecule looks like. So that is a compound. So compounds are a mixture of elements that come together to create a new material. That's what chemists do. Now, right here, for instance, this. Right here, we have our oil. And our oil doesn't react with our water. So this anti-acid tablet is not soluble in oil. So what I'd like you to do now, get another cup on the side and take your oil and pour some oil in your cup. You don't need a lot, just a little bit. Just enough to allow your anti-acid tablet to sit in there. So I'm going to take this anti-acid tablet and I'm going to sit it in the oil. Look, there's nothing really happening. There's some little, very, very small amount of particles starting to release from the top of our tablet, but there is no real reaction happening here. All we just see is a little bit of bubbles and suds starting to accumulate. Perhaps that is the water that may be inside of our anti-acid tablet, or it's probably some gas bubbles that are starting to, yep, that's what that is, gas bubbles. So there are some gas bubbles starting to release from our anti-acid tablet, but it's not reacting with the oil. What's happening is the oil is allowing that gas that's trapped inside of our tablet to be forced out. So the oil is so heavy, it's pushing down on this gas that's inside that tablet, and it pushes the gas bubbles out of the tablet, and the gas bubbles are lighter than the oil, so the gas bubbles float to the top. And that's what's going on here. So we'll take this out. Take that out just like that. Now, we are going to take our cup, another cup. It's another cup on the side, and we're going to add some water to it. Add water to that cup. So we just did the oil, as you can can see, nothing happened. Now we're going to take our water. So this is our water. I'll add some food coloring to it. Let's add some pink just so we can stay with the pink. So now there's some food coloring added to my water. Now this has some oil on it, so the oil's not going to react with the water. So let's see what happens when we put this in water opposed to putting it in oil. Now this was not soluble in our oil. We just saw that. It did not dissolve. It didn't break down. All it did was release the gas bubbles that were already inside. Now, when I take this and drop it in the water, let's see what happens. In 3, 2, 1. You'll see immediately those gas bubbles are really releasing themselves from the solid. And it's starting to bubble and bubble. And you can see there are bigger and larger bubbles that are starting to form inside of our cup here. Now, this is happening very slowly because the surface area of our, surface area. So the surface area of our tablet was a lot smaller than if I was to take this and crumble it up into very small tiny pieces, such as this powder here. So this powder is has a very high surface area because all around it the liquid can come in contact. But the only part of this that was being in contact with the liquid was the surface. So if we create more surfaces, thus splitting it in half, now we've created a surface here and a surface here. So we've created another surface there. So just by breaking it in 3 parts, we've made 1, 2, 3, 4, 5 new surfaces, opposed to the 2 surfaces that we first started out with. So then I'll take it and I'll crumble it up even more into 100 surfaces, because now we got that powder. And as we increase the surface area, you'll see now there's a lot more reactivity happening. So there's a lot more reactivity if we increase the surface area. And you can hear the bubbles now because there's more of our anti-acid tablet being broken down. That's why it's good to chew your vitamins. Let me get out another anti-acid tablet. And what we want to do here is take this anti-acid tablet and we just want to use 2 pieces. So break it into 2 pieces. What's going to happen is we're going to drop these into our container, and that oil is going to coat our pieces of anti-acid tablet. And as the oil is coated, it's going to drop down in the liquid. That other liquid is water. And remember, oil and water do not mix. So what happens is the oil that was on top of our anti-acid tablets starts to then float back to the top. But not only just that, we also are creating carbon dioxide gas bubbles that then create a cyclic motion, a cyclone. It starts to go in a circle and make a rumble, just like a lava lamp. So here we go. Y'all ready? In 3, 2, 1. So as you can see, it slowly went down, and now it's going to create these bubbles. And as those bubbles start to go up, you'll see the bubbles even also have some of that water. And remember, the water doesn't like to be on top of the oil. The water would rather be on the bottom. So what's happening is the water that is in the bubbles then starts to get way down and go down below the oil. Turn it on this side so you can see on this side. And this will keep on reacting until all of our anti-acid tablet is dissolved. Because remember, it is soluble in water, but it is not soluble in oil. And you'll see now all that water that was around our bubbles, our carbon dioxide bubbles, which are popping on top, on the surface now. And as that gas pops and releases, the liquid, the water that was also on that bubble gets then weighed down and is heavier than the oil, so it starts to sink to the bottom. Let's move on to liquids, solids, and gases. So what we have is our empty bottle. So you can have a water bottle, whatever bottle you like. We also need our baking soda. Pull out our baking soda. The spoon that you were using for your cornstarch. And what we're going to do, and our vinegar. We need our vinegar for this as well. What we're going to do is take our baking soda. Baking soda! So another name for baking soda is called sodium bicarbonate. Say that, sodium bicarbonate. And sodium bicarbonate is a base. And we're going to put our base on our base. So just like we did with our cornstarch, and we want to sprinkle some of this around on our plate. Set this to the side. And now what we're going to do is get another cup, and we are going to take our vinegar out. Vinegar is very stinky, so be careful when opening it. You don't want to smell it directly. Take our vinegar, pour your vinegar into your cup. For this, you can add some food coloring if you like. We'll do the food coloring part here in a second once we get to our bottle. Pull out my pipette. You have a pipette. And what we're going to do is take this vinegar, which also has another name called acetic acid. Say that, acetic acid. So acetic acid is an acid that we are then going to react with our sodium bicarbonate, which is our base. So acid and base reactions are very common in industries. So what we're going to do is dropwise, and I'll hold it up so y'all can see. I'm going to take this and I'm going to drop. And as you can see, it's starting to sound off. And you can hear the gas being created between our acetic acid and our sodium bicarbonate. This gas is also carbon dioxide. Carbon dioxide. The same gas we use to blow up balloons with. So this balloon has that same gas inside. The same gas that we saw being created and developed in our bubbles here. This gas is fast. So that gas is so fast, it just flew outside of my balloon because I allowed it to. This balloon now has gas in it and it's trapped inside. This gas is trapped inside because I'm pinching it. I have to apply some type of force to it in order for this gas to stay trapped. Opposed to right here, I take the vinegar and I put it on my plate. These gas bubbles are eventually popping and that gas is going right back into the atmosphere or this room. But right here, I can take this and then tie it into a knot because this polymer is elastic. Another great word, say elastic, elasticity, elastic. The ability for something to be stretched. Stretch it out. So it's elastic, and I'll take it and tie it in a knot. So now, as this is in a knot, this gas is inside. And you can see I'm moving the gas around. This gas inside is bouncing around with a lot of energy. So much energy that it's inflated this balloon. And if you push on it, the balloon starts to take a different shape because the gas that's inside of here still exists. It is matter. It's just microscopic matter that we can't see with our eye. Just like the gas molecules that make up this room. There's a lot of gases in this room flying around. We just can't see them because they're so tiny, so microscopic. But the more and more and more that those molecules and atoms start to come and take different types of shapes, we can see them more, just like liquids, just like solids. The more the matter, the more the matter. All right. So now we're going to take our empty bottle, and we're going to transfer the vinegar that we had in our cup into our empty bottle, just like that. Boom. Let's add some more vinegar to this. We don't want to waste, of course. Add some more vinegar. There we go. You want to put about a third full of vinegar. Now we'll add our food coloring. I'll take blue. Add some blue food coloring. There we go. And give it time for it to get nice and dissolved in there. Very nice. Now, take another balloon, and we want to stretch the top of it, because remember, this is elastic. Stretch the top of it so that you can easily put in some baking soda. So I'll use the 3-finger method. Get a spoonful of baking soda and just put it right on in like so. You can do 2 spoons if you like. Increased learning. If you want to take this to another step, you can do this with 3 different types of bottles. One bottle that is filled with vinegar, one bottle that is half full with vinegar, and the other bottle with about a third or a quarter of the way full of vinegar. And then with each of those, you decrease the amount of baking soda that you use. Fun times. Fun way to do the experiment. So now with this, we want to stretch out the top of our balloon and just put it over the top of our bottle without the solids getting down inside. So now you can see, I can pinch it right here so the solids don't come out. But you can see now, this is a closed system. Opposed to right here, we have this as an open system. And with this being so much of an open system, these bubbles have the ability to pop and go out into the atmosphere. Opposed to in here, when we create those bubbles and the gas that's inside those bubbles have to go somewhere. So in science, nothing is created nor destroyed. It either is transferred into something or transformed into something. The energy is utilized elsewhere. Yeah, you can research that too. What we're going to do, hold up your bottle. Now we're going to react our acid with our base. And by doing so, we add our baking soda, which is in the palm of my hand, in our balloon, down into our liquid, just like this. Y'all ready? 3, 2, 1. There we go. And as you can see, just like that, it's already started to create a lot of bubbles. And those bubbles have that carbon dioxide gas inside. And the gas goes up into this balloon and pops. And once the bubbles pop, they have the gas is still inside. The gas still inside, so it goes and it's inflating our balloon here. And down below you can see the bubbles still being created. And then we'll shake it so that we can get those bubbles to rise to the top so that they're not trapped under any liquid. And once all the bubbles are popped, this reaction is complete. Boom! Balloon! Alright, let's recap. So we started out with Oobleck. Remember that Oobleck, the cornstarch and water that then turned into a non-Newtonian fluid. That fluid had tendencies of a solid and liquid. So as you can see, here's our Oobleck. It looks like it's a solid. I'll push up against it and you can see that there are also some that are acting as if it is a liquid. Nice and stringy, as if it's melting. I'm melting. But also, the energy that you give it, it absorbs. So if you give it energy, the solids that's inside will absorb that energy and then stiffen up. But when you allow those molecules to relax, the material acts more as if it's a liquid. Science! Also, we did our oil and water experiment with our anti-acid tablet. Remember, oil and water do not mix because of surface tension. The weight of the water is pushing up on the oil, and the oil is so lightweight that it's just resting ever so softly. It's resting ever so softly onto the water because it doesn't have enough weight to push down and move the water out of the way. It just sits right on top, just like that. But if we introduce an anti-acid tablet, that anti-acid tablet gets coated with oil. That oil pushes down. Then the oil also starts to rumble and move around and bubble, toil and trouble, and it creates gas bubbles. That gas, carbon dioxide gas. That gas then pops once it reaches the surface, and once the gas pops at the surface, the water that was still trapped on that gas bubble goes right back down to the bottom because the water weighs more than the oil. What you could do if you have a scale at home, you could weigh out 2 milliliters of water and then weigh out 2 milliliters of oil. See which one weighs more. And also we did our baking soda experiment with vinegar. Remember, those are our acid and base experiment. The base being our sodium bicarbonate and the acid being our acetic acid, also known as vinegar, also known as baking soda. And what that created was also carbon dioxide gas. And that gas is still trapped right here in our balloon. See? Nice and tight balloon. Go ahead and take this off. And you can see there's gas inside of here. The gas exists. It is matter. I'll let this go and boom. Thank you all for joining me on this journey of experimenting. Remember, practice safe science. We do not eat or drink when doing science experiments, and always have supervision of an adult. Practice safe science, everyone. See you next time. See what I'm going to do with this Oobleck real quick. There's some water leaking off, but watch this. Look at it. Look at it. Let's turn it sideways. Science! Then turn it upside down. Science!